let's move on to the KDE plots. The KDE plot replaces every single observation on the rug plot with a Gaussian normal distribution curve centered around that mark. So for each of these dash marks, it will create a normal distribution curve and then adds up the y values for all of the x values on the plot. As you can see on this diagram, here for the same data set, we have two different figures here. On the left one, we have a histogram, and on the right one, we have kernel density estimate, which is constructed using the same data. So here, if you look at this bin, there are two data points inside this bin. So this bin is higher than the other bins, all of which has a single data point. Now for KDE plot, for each of these data points, imagine this red curves which are normal distribution built around each of the data points. So the peak of this red curve would be at this data point and then it will taper off on both directions. Now for KDE estimate, all of the values of y at a particular x values will be added up and this will give us a smooth blue curve which will be the kernel density estimation. So basically what is the density of that particular kernel on the x-axis, it will give us an estimation. So on each of these data points, a normal distribution curve is built with the mean of that data and standard deviation of 1.5, and then for each value at the x-axis, the corresponding y-axis for each of these normal distribution curves is added up and is plotted using this blue curve here. So to plot this, we can use sns.kde plot, pass in your data which is tips, and then on x we can use total underscore bill and it will give us a KDE plot. Here we can also plot both KDE and rug plot together as well, and you will get this plot. This is useful for analysis of univariate data if you want to know the rough estimate of where a particular data could lie. However, if you want the exact distribution of the data, you should use histogram.